Hey guys, this is Mrs. Schrader, and we're back with Lesson 3 video. So this is your Lesson 3 video, and in your notebook, this is page 8. Page 8 in your notebook. So again, make sure you're taking notes, making sure that you are staying organized. There will be notebook checks, so make sure you are keeping a good notebook. We're going to start today with the distance formula. So I'm going to go ahead and write it down. D is for distance. Distance equals the square root, and I'm going to draw a really big square root there. X2 minus x1 with parentheses around it, all squared, plus sign. I have to make that even longer. Y2 minus y1, all squared. So we're going to use this formula to find the distance between 2 points on a coordinate grid. Now we're going to start though with 2 points on the graph. And actually before we use the formula, before we dive right into that formula, I'm going to show you something you could have done maybe back in middle school. So back in middle school, you probably learned something called Pythagorean theorem. A squared plus b squared equals c squared. And the reason why I bring this up is because the distance formula is actually from Pythagorean theorem. It comes from that, and we'll kind of show you that in class. We'll explain more about why that's the case. But you can use Pythagorean theorem to find the distance between 2 points on a graph. So if you look over here, I've got these 2 points. I got this point right here at, looks like -5, comma 3. So I'll call this point A. So A is at -5, comma 3. And then I have this another point down here. And we'll call this point B. And it looks like point B is at -2, -3. And we're going to find the distance between those 2 points. Again, I'm going to start with Pythagorean theorem, though. So if I were to draw this into a right triangle, if I were to go ahead and connect vertically and horizontally into a right triangle, this could be my A side, my B side, my C side for Pythagorean theorem. So my A side, if I count, let me use a different color here. If I count, it's 1, 2, 3, 4, 5, 6. So that means A would be 6. And then my B side, if I count 1, 2, 3, my B side is 3. So A squared would be 6 squared. My B would be 3 squared equals C squared. 6 squared, of course, is 36, and 3 squared is 9. And when I add those together, I get 45. And then to find C, which is the side we're looking for, C is the length from A to B, I just take the square root of both sides. And if you have a calculator, you can take the square root of 45. And it's approximately, use my little approximate sign there, 6.7. And that looks pretty reasonable, wouldn't you say? If it looks like it's a little bit big, though this side right here looks a little bit bigger than the side that was 6. So 6.7, that's pretty reasonable, wouldn't you say? So that's how, if you're on a graph, you could find distances just by using the Pythagorean theorem. Now, if you're not on a graph and you're just given 2 points, you can also use the distance formula. So we're going to try that next with number 2. And so what we're going to do is we got points A and B. We don't have a graph, but you can, if you wanted, you could come over here and you could sketch a graph. You could say, okay, -4, 1 is right about there. 3, -1, it's right about there. So we're finding the distance from A to B. This is A and this is B. So using the formula, we're going to assign each of these points an x1 or an x2. So for point A, we'll call this x1, -4 is x1, and 1 is y1. And then we've got x2 and y2, okay? So now when we plug into our formula and look up at the top, it says it's x2 minus x1. So x2, if you take a look, that's 3, and x1 is a negative 4. And we have a minus in the middle, so it's minus a negative 4, parentheses squared. And then we're going to do the same thing with the y's, y2 minus y1. y2 is negative 1 minus y1, which is 1, all squared. So now we're just going to figure out what this is. So 3 minus a negative 4, well, 3 minus a negative 4, that's the same as 3 plus 4. So that is 7 squared. And negative 1 minus 1, that's negative 2, all squared. And don't forget the big square root right here. So what's 7 squared? Well, 7 squared is 49. And what's negative 2 all squared? That's positive 4. And when I put that together, that's the square root of 53. And now we're just going to do that in our calculator. Second square root of 53, which is approximately 7.28. I guess you could round that to approximately 7.3 if we were rounding to the nearest tenth. So that would be approximately 7.3. If I look over at my graph, 7.3, that looks pretty reasonable. That looks like that makes sense. That could be 7.3. Let's try one more example here. So now we've got points E and F. So what we're going to do is we're going to start with assigning E and F x1, y1, x2, y2. So x1, y1, x2, y2. And now we're going to plug into our formula. So remember, if I look back up here at the top, I'm going to kind of go back to the top here. The formula says it's x2 minus x1, x2 minus x1. So x2 was 11 minus x1, which is a negative 7. Put it in parentheses, squared. And then we're going to do y2 minus y1. Again, look back up here at the top. y2 minus y1. So that's going to be 3 minus a negative 2. And again, it's all squared. All right, so we got another minus a negative, which we know that means plus. So 11 plus 7, that's 18 squared. And then, oh, we got another one, minus a negative right here. That's also a plus. So 5 squared, so take the square root of all of that. So let's see, 18 squared is 324. And 5 squared is 25. Take the square root of that. So I'm going to add them together first. So the square root of 349. And if I take the square root of that, I get approximately 18.68, which is about 18.7. And again, if you wanted to graph those 2 points on a graph and see if that looks reasonable, you could definitely do that. The other formula I want to introduce you to today is the midpoint formula. The midpoint formula is this. We use a capital M to represent midpoint. And it's x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, all in parentheses. The reason why we are using parentheses here is because the midpoint is going to be a point on a graph. So it says find the midpoint of GH given G is 7, negative 5, and H is 9, negative 1. I'm going to sketch it over here so we can take a look at what we're finding the midpoint of. So 7, negative 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So 7, negative 5 is right here, that's G. And then 9, negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1, so that's about right there. So we're trying to find the midpoint of that segment. We're trying to find what point is right in the middle, right there. That's what we're trying to look for, the midpoint. I'll call that capital M. What point is that? So we're going to do the same thing as what we did with the distance formula, and that we're going to assign x1, y1, x2, and y2. We're going to go ahead and assign those. So we're finding the midpoint. We're going to plug in. Now it's x1 plus x2. So here's our x1 plus our x2. So 7 plus 9 divided by 2. And then y1 plus y2. So negative 5 plus negative 1, all divided by 2. So now, let's see. We've got 7 plus 9, which is 16, right? 16. And 16 divided by 2, which is 8. And then negative 5 plus negative 1 is a negative 6. And then negative 6 divided by 2 is a negative 3. So that means the midpoint is at 8, negative 3. And I can look over here at my graph. Does 8, negative 3 look reasonable? And it does. I mean, had you made a mistake and you had gotten, say, let's negative 8, negative 3, and you ended up over here, you could have been like, yeah, there's no way that's the midpoint of that segment. So one thing I love about midpoint is that if you make a graph, it's super easy to check it. Okay, let's try this one more time. So we got number 5 here. Find the midpoint of AB. I'm going to go ahead and graph it again. So let me erase this graph, and we're going to start over with a new one. And let's see. Okay. So negative 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So right here, and that's A. That's point A. And then point B is at positive 1, 2, 3, negative 4, 1, 2, 3, 4. So right here is point B. And again, we're trying to find the midpoint or the middle of that line segment. So let's do the same thing. Let's go ahead and assign x1, y1, x2, and y2. And plug in. So remember, it's x1 plus x2. So that's negative 7 plus 3. And then y1 plus y2, so that's 4 plus negative 4. And then let's calculate this. So negative 7 plus 3 is negative 4, and negative 4 divided by 2 is negative 2. And then 4 plus negative 4 is 0, and 0 divided by 2 is 0. So the midpoint is at negative 2, 0 right here. Now my graph isn't perfect, but you can tell it's close, and the only reason it's not perfect is because I didn't use a straight edge and graph paper. But yes, that does look reasonable for the midpoint to be at negative 2, 0. So that's it for this video. Thanks for watching, and again, make sure you keep this in your notebook for your notebook check. All right, we'll see you later. Bye-bye.